Picture this. A brutal red pen strikes right across the page. Imagine opening your Cambridge IGCSE computer science exam results, fully expecting a top grade, only to realize you've lost critical grade boundary marks on a topic you honestly thought you had totally mastered: input and output. Well, in this explainer, we're going to look at exactly how to rescue those lost marks and code in Visual Basic the exact way examiners demand.
So you're in the exam and you write a line of code like x equals input, enter number. It makes sense, right? Well, the devastating result from a Cambridge examiner: 0 marks. Nothing. This is an incredibly common, heartbreaking mistake. Students walk into paper 2 having practiced with generic pseudocode or maybe a bit of Python, and they write this generic syntax into a Visual Basic question. But the examiner isn't looking for general concepts here. They are looking for specific Visual Basic methods.
Okay, let's dive into this. Why exactly did this perfectly logical instruction completely fail to meet the examiner's technical requirements? The logic is totally there, but the language is just wrong. To write mark scheme safe code, you don't just need to know what you want the computer to do, you have to understand the specific environment you are asking it to operate in.
That brings us to Section 1, Console versus Windows Forms, choosing your environment.
You essentially have two main paths here. The console application is your bare-bones textual command line interface. It's completely uncluttered by graphical elements, which honestly makes it the absolute perfect environment for testing pure algorithms and logic, and that is highly relevant for your syllabus. On the flip side, the Windows Forms application gives you a full graphical user interface, or GUI. This is where you get your buttons, text boxes, and menus. It behaves much more like a commercial piece of software you'd use every day.
Now, that graphical environment brings us to a really crucial concept: event-driven programming. When you build with Windows Forms, your program basically just waits. It sits there waiting for user-controlled events, like clicking a submit button, to actually trigger the execution of your subroutines. In a moment, I'm going to show you the exact examiner clue to fix our 0-mark answer from earlier. But first, you really need the translation framework to get your logic straight.
Moving on to Section 2, Pseudocode to Visual Basic, translating the logic.
So here is the exact translation flow you need. Step 1 is your syllabus pseudocode, something like input number 1. That's your abstract logic. Step 2 translates that directly into a concrete Visual Basic method, which is console.readLine. This is how you actually fetch the input in a console app. And Step 3 completes the whole cycle with the output method, console.WriteLine. You're basically mapping your abstract algorithmic thinking directly into the precise language vocabulary that examiners want to see.
The crucial takeaway here is that when you write these programs, you're interacting with the console class. This class provides a massive library of methods for command line interaction. And here's a fantastic little tip for when you're actually programming in the Visual Studio IDE. When you type the word console followed by a dot, a window pops up. This is auto-completion, and it instantly lists methods like readLine and WriteLine. Getting comfortable with this feature is a game changer that will save you precious time when practicing before the big day.
All right, Section 3, spot the code error, the pause and predict challenge.
Now, what's really interesting about this next setup is we have a highly realistic student mistake here. I actually want you to pause this explainer right now. Look closely at this conditional code snippet. What is the fatal logic error hiding in these 4 little lines? Take a second and predict the problem.
Did you spot it? The error is inverted logic. If the number is greater than 0, meaning it's a positive number, the code says to reject it, and it accepts everything else. A simple flip of the logic like that literally ruins a perfectly written algorithmic structure. And hey, while we're on the topic of checking data, the syllabus gives us a very strict warning. Do not confuse validation, which checks if data is reasonable or sensible, with verification, which just checks if the data was entered accurately. They are not the same thing. To catch awful inverted logic errors like the one we literally just saw, you have to ruthlessly test your code. The Cambridge syllabus requires you to know 4 essential test data types. You've got normal data, which should be accepted, abnormal data, which should be rejected, boundary data, which tests the absolute limits of your accepted range, and extreme data, which is just way outside the expected parameters. Rigorously applying these 4 types is exactly how you guarantee your algorithm functions perfectly under pressure.
Which leads us perfectly into Section 4, upgrading for top marks, the examiner's secret. Listen, before you write a single line, you absolutely must decode the command words. If the question says state or define, they just want concise facts, no fluff. If it says describe, you must give characteristics. If it asks you to explain, you have to provide the why or the how. And if it says compare, you are required to present both sides of the argument. Ignoring these command words is for sure the fastest way to write a brilliant answer that somehow scores 0 marks.
And that brings us to the ultimate, non-negotiable rule of Cambridge exam strategy, the rule of 1. 1 mark usually requires 1 distinct technical point. If a question is worth 3 marks, you need 3 separate, distinct technical points. Never, ever repeat the same point using different words. The examiner is just not going to give you credit twice.
Let's actually see how this builds a top-tier answer. A typical student response might be something vague like, get the number and print it. That's going to score low, but applying our precise framework transforms it into use console.readline for input assigned to an integer variable and output via console.writeline. Look at the difference. It's super specific, it uses the correct Visual Basic syntax, it explicitly mentions variable assignment, and it nails the exact methods.
If you want to see the absolute gold standard for Paper 2 programming logic questions, it looks exactly like this. By writing number equals console.readline correctly assigns the user's commands line string input to the defined variable identifier, you are proving to the examiner that you understand the input method, the data format, and the concept of variable assignment all in one concise mark scheme safe sentence. That is how you win. Finally, we hit Section 5, the final hurdle, mastering time. Because knowing the perfectly optimized answer is one thing, right? But how do you actually write these flawless, top-band answers while the exam clock is aggressively ticking down? Without a ruthless, systematic approach to timed answer writing, even the most perfect programming knowledge is going to collapse under the pressure of exam day. You absolutely cannot afford to let time rob you of the grade you deserve. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Your next vital step is to click on our next explainer, where I'll break down the exact step-by-step timed answer writing system you need to beat the clock and secure every single mark. Are you going to let the clock steal your A star, or are you going to master it? Go watch that right now, and I'll see you there.